Hello and welcome to this video lesson on secure software testing.
This chapter is crucial for understanding how to ensure the security of software through comprehensive testing. We'll cover various subtopics, including the development of security test cases, attack surface validation, penetration testing, fuzzing, scanning, simulations, failure modes, cryptographic validation, regression testing, integration testing, and continuous testing.
Let's start with security test cases.
A security test case is a document that describes an input, action, or event expected to produce a predictable response. The main aim is to ensure that specified features in a system or software product are working correctly.
Preparing test cases early in the development process helps identify potential problems in requirements or design. Test cases should include an identifier, name, objective, test conditions or setup, input data requirements, steps, and expected results. Testing involves examining the system under controlled conditions, including both normal and abnormal conditions. We have two main types of testing: white box and black box.
White box testing examines the code's internal structures, while black box testing focuses on the software's functionality without considering the internal code structure.
Next, we have attack surface evaluation. The attack surface is the set of points where an attacker can enter a system. During the design phase, we evaluate risks and mitigation efforts associated with various entry points. Documenting the actual attack surface throughout the development process is crucial. A tool like Microsoft's Attack Surface Analyzer helps measure the security impact of an application on a Windows environment. Moving on to penetration testing.
Penetration testing actively examines the system for weaknesses and vulnerabilities. The process involves four main steps: reconnaissance, attack and exploitation, removal of evidence, and reporting. Penetration testing can be done using white box, black box, or gray box methods.
Let's talk about some common testing methods. First, fuzzing. Fuzzing is a brute force method for addressing input validation issues. It involves applying large numbers of inputs to find faults and potential vulnerabilities. Second, scanning. Scanning is the automated enumeration of specific characteristics of an application or network. Third, simulations. Simulations involve testing the application in an environment that mirrors the production environment. Fourth, failure modes. Failure mode testing identifies errors and defects, even those that don't cause a failure in the current version. And finally, cryptographic validation. This ensures the proper implementation of cryptographic functions, random number generation, and key management. Next is regression testing. Regression testing involves testing changes applied to older versions of a code base to ensure no adverse impact on other aspects of the software. As software evolves, regression testing becomes crucial to maintaining stability across different versions. Then, we have integration testing. Integration testing ensures that the integration of components occurs as designed and that data transfers between components are secure and proper. The objective is to verify that the system is compliant with system-level requirements. Lastly, let's discuss continuous testing. Continuous testing involves automated testing as part of the software delivery process to provide rapid feedback on business risk issues associated with a software release candidate. It integrates testing within the development process and continuously reviews the test suite to optimize risk reporting. In conclusion, we've covered the critical aspects of security test cases, including their development, attack surface evaluation, penetration testing, common testing methods, fuzzing, scanning, simulations, failure modes, cryptographic validation, regression testing, integration testing, and continuous testing. Each of these components plays a vital role in ensuring the security and integrity of software throughout its lifecycle. Thank you for joining us in this lesson on secure software testing. Let's quickly recap. Security test cases are essential for verifying software features. Attack surface evaluation identifies potential entry points for attackers.
Penetration testing mimics attacker methodologies to find vulnerabilities.
Fuzzing and scanning are critical for finding input validation issues. Simulations help ensure software performs correctly in production-like environments. Cryptographic validation ensures secure implementation of cryptographic functions. Regression testing ensures changes do not break existing functionality. Integration testing verifies the secure integration of system components. Continuous testing integrates automated testing within the development process for rapid feedback. Thank you for watching, and we'll see you in the next video.